A very good morning, students. After a long gap, we are meeting again. And as you know, the situations are जैसे देश दुनिया के हालात हैं वैसे नहीं लग रहा है कि स्कूल फिलहाल अभी खुलने वाला है और आप लोगों को पूरे सीरियसनेस के साथ पढ़ाई करनी है क्योंकि बोर्ड एग्जामिनेशन तो होने ही है। भले सिलेबस कुछ रिड्यूस हो जाए लेकिन फिर भी पढ़ाई तो करनी है, तो पूरे सीरियसनेस के साथ हम लोग शुरू करते हैं। लास्ट क्लास में आई थिंक आई लेफ्ट द टॉपिक that was lecture 15 that we are discussing refraction by spherical lenses. So first of all, a quick revision that we have discussed in the last class. The first question was, what is a lens? Lens क्या है? What is a lens? तो lens is a transparent material. I think you have written also. A lens is a transparent material. Transparent material, it may be of glass, it may be of any transparent polymer. So a lens is a transparent material which is bounded by two surfaces, out of which at least one should be spherical. तो एक लेंस इस तरह का हो सकता है, अब देखिए two surfaces are spherical, but we have said that at least one should be spherical. तो इस तरह का भी लेंस हो सकता है जिसमें एक प्लेन हो एंड एक जो है ये हो गया डबल कॉन्वेक्स। और सिंपली कॉन्वेक्स, दिस इज प्लानो कॉन्वेक्स, वन सरफेस इज प्लेन and another is convex. So double convex or plano convex. Now the surfaces are like this also. So this is concave, or you can say double concave or simply concave lens. Then one surface is plane and another is concave, so it may be a plano concave lens. So in last class, as we have discussed, a lens is a transparent material bounded by two surfaces and out of which one should be a spherical. Now you can get any question if you have to differentiate between a double convex lens and a double concave lens. You can say that a double convex lens, it is thicker in the middle and thinner at the edges. A double convex lens is thicker at the middle and thinner at the edges, and concave lens is just opposite. It is thicker at the edges and thinner at the center. From diagram it is clear, isn't it? It is thinner at the center and thicker at the edges. Now there are other differences, but we will discuss the differences. First we will know the important terms related with spherical lenses. So let us discuss the important terms related with spherical lenses. important terms related with spherical lenses. So the first important term is the center of curvature. First important term, center of curvature. And we represent center of curvature by a symbol that is capital C. So first try to understand what center of curvature is. Center of curvature, first suppose there is a convex lens. Double convex lens or convex lens. So how many surfaces, spherical surfaces it has? There are two spherical surfaces. Now we can assume that these two spherical surfaces are part of a hollow glass sphere. So we can construct a hollow glass sphere considering these two spherical surfaces like this and another one like this. So we can assume that these two curved surfaces are part of two hollow glass spheres. Now a sphere has a center. So suppose center of this sphere is here. You can mark it as C1, and this is center of another sphere. You can mark it C. Then these C1 and C2 are center of curvature of the lens. We can represent it in case of concave lens also. A double concave lens is like this. This is a concave lens. So we can assume that these two curved surfaces are part of two hollow glass spheres. So okay, like this, and this can be drawn like this. So these two spheres has center. Mark it as C1, and this is where suppose the center is C2. So C1 and C2 are the center of curvature of the lens. So write a definition for it. Write a lens, either a convex lens, either a convex lens or a concave lens, has two spherical surfaces. Each of these surfaces forms a part of a sphere. Each of these surfaces forms a part of a sphere. The centers of these spheres are called center of curvature of the lens. Now another important term, second one, principal axis. Now in the previous diagram, if we join these two centers C1 and C2 with a straight line, then this line, this straight line is called principal axis. An imaginary straight line which passes through center of curvature of the lens. So write about principal axis, and you also mark in your diagram the line. An imaginary straight line, write down an imaginary straight line passing through the two centers of curvature, of the lens is called its principal axis. So these lines are known as principal axis. The third important point is optical center. And the symbol for optical center is O. The symbol for optical center is O. So optical center is central point of the lens. Optical center is central point of the lens. So mark a point O at the center of convex lens, and here also mark O, the center of concave lens. So these points at the center of a lens are known as optical center, and there is an important characteristic of this point, that if a ray of light passes through optical center of a lens, then it passes straightway, no refraction takes place. The ray will suffer no deviation if it will pass through optical center of a lens. तो ये एक इम्पॉर्टेंट बात है ऑप्टिकल सेंटर के बारे में कि अगर कोई रे ऑफ लाइट ऑप्टिकल सेंटर से गुजरता है तो वो स्ट्रेट उससे निकल जाता है, कोई डिविएशन, देयर इज नो deviation, no refraction takes place, it will pass straight like this. So no use to draw this line, but you write a definition for optical center. Write the central point of a lens, is called optical center. You also mention a ray of light. In same topic you write a ray of light passing through optical center. A ray of light passing through optical center of a lens passes straightway without suffering any deviation. Written? Now fourth term is aperture. First, mark it what aperture is. You mark it with a dotted line, the effective diameter of the outline So in the same diagram which you have drawn, mark the aperture with the dotted lines. And write about aperture. Write the effective diameter of the circular outline. The effective diameter of the circular outline of a spherical lens is called its aperture. So the effective diameter of the circular outline is called its aperture. So these are the 4 terms. 2 more terms are there, and we have to draw another diagram to discuss the 2 more important terms. The terms are principal focus and focal length of the lens. So let us see what principal focus is. Next term, it means the 5th term is principal focus, or we can say simply focus, and the symbol for principal focus is capital F. Symbol for principal focus is capital F. So first we draw these diagrams to explain what principal focus is. Suppose we have a double convex lens. This is convex lens. Mark a point O at its center. As you know, this point is optical center of the lens. Then draw its aperture, the effective diameter of the circular outline. So this dotted line represents aperture. Then draw a straight horizontal line through O, and this line is principal axis. So if parallel rays of light, suppose these are the parallel rays of light, falls on a spherical lens. Suppose these are the parallel rays of light falling on a convex lens. So a convex lens converges the rays of light, isn't it? And then the rays meet at a point. As you know, it is similar to a magnifying glass. When you take a magnifying glass and just place it in a strong sun, it will concentrate the sun rays. And if you will take a paper and keep it for some time, it will concentrate the parallel sun rays and the paper starts burning. So the same thing, so it converts the parallel rays of light to a single point like this. Arrows are very important, and suppose the parallel rays of light meet here when they converge. So this point where the parallel rays of light meet after refraction, that point is called principal focus of the lens. And your focus is real. Real means the rays are actually meeting after refraction. Now you can show it in case of a concave lens also. So we will draw diagram for concave lens. So draw a concave lens. Similarly, mark a point O at the center of the lens. This point is optical center. Then draw the aperture with dotted lines like this. Then draw the principal axis, a horizontal straight line passing through optical center of the lens like this. Now, in case of concave lens, this is concave lens. If parallel rays of light falls on it, suppose these are the rays. So suppose parallel rays of light are falling on a concave lens. So this lens will diverge the rays of light. It will not converge as in case of convex lens. It will diverge. It diverges the parallel rays of light. So if you will produce it backward, similarly this ray will diverge. Similarly all these rays will diverge. So it appears they are just coming from a point. So here the focus is virtual because actually the rays after passing through a concave lens, they diverge. They are not meeting at a point. But when they are produced backward virtually, then they meet at a point. And this point is called principal focus. But here focus is virtual. फोकस यहाँ पे काल्पनिक वर्चुअल. So write definition for principal focus now. Write down when parallel rays of light falls on a spherical lens, when parallel rays of light falls on a spherical lens, written when parallel rays of light falls on a spherical lens, they meet at a point after refraction. They meet at a point after refraction on principal axis. This point is called principal focus. This point is called principal focus of the spherical lens. This point is called principal focus of the spherical lens. Now the last term, that is the sixth term, is focal length. The symbol is small f, focal length. So focal length is simply the straight line distance between optical center and principal focus of a lens. This distance between optical center and principal focus. So write it. The straight line distance between optical center and principal focus of a spherical lens is called focal length of the lens. It's called focal length of the lens. Now these terms are very important. Altogether we have 6 terms as we have discussed. First one was center of curvature, second one was principal axis, then we have optical center, fourth aperture, fifth is principal focus, and sixth one is focal length. And I think you are able to understand these terms. If you have any doubt, you can ask, because in next class, which is tomorrow, we will again discuss a very important topic, that is image formation by spherical lenses. And every year we are getting questions in board examination from that topic, the image formation by spherical lenses. So very important topic, and we have to use these terms frequently there. So you must know what the terms are, what is center of curvature, what is aperture, what is principal axis, what is principal focus and focal length. So must go through it, and tomorrow we will discuss another important topic, that is image formation by spherical lenses. And I will give some homework that I will give in your WhatsApp separately. In group I will give some questions based on it. Okay. So for today we will discuss this much.